And now for part C, which is the last part. C, we are given y equals to x squared out of 16. And we are differentiating from first principles. And the formula says dy dx equals to limit as h tends to 0 for the functions f of x plus h minus f of x over h. So we need to get f of x and f of x plus h. How do we get f of x? Remember, this is a function y which has been defined in terms of x. So we say let the function y be f of x, which doesn't change the meaning. It means that we have a function defined in terms of x. So the function y is in terms of x. Therefore, f of x is x squared out of 16. So we have f of x now. What don't we have? We do not have f of x plus h, but we can get it simply from f of x. What do we do? Where we find x, we put x plus h. So here we have x squared. So in the position of x alone, we shall have x plus h. But then we're saying x squared out of 16. All the other terms remain the same. What we substitute for only is x as x plus h. Now we need to expand the bracket using one of these methods, but we are using operation of brackets. This gives us here x squared plus 2xh plus h squared, but over 16. This is f of x plus h. Now, after getting f of x plus h, we simply need to get the difference. That is f of x plus h minus f of x as the formula states. So that we simply substitute for our result at once. So f of x, our markers. So f of x plus h minus f of x becomes, this is f of x plus h. Now, if you look at this now, there is a denominator 16, which applies to all the terms. So let us distribute the denominator. It gives us x squared out of 16. Every term divided by 16 plus 2xh out of 16 plus h squared out of 16. Yes, every term divided by 16. Then we say minus f of x. F of x is a single term. So we can just say minus x squared out of 16. Then we simplify. X squared out of 16 minus x squared out of 16. That will give us 0. They cancel out. So we are left with this term and this term. Now here we can simplify by 2, 1 by 2, 8. That gives us xh out of 8 plus a squared out of 16. That is the difference of the two functions. Therefore, dy dx becomes limit as h tends to 0 for the difference of the functions. And the difference is what we have here. That is xh out of 8 plus h squared out of 16. That is the difference. But we are saying over h. So out of h, because the numerator is the difference, but the formula says divide the difference by h. So we look in that now. This means that we need to divide all the terms by h. So shall have limit as 8 tends to 0. So if we divide this term by 8, it gives us x out of 8 plus, if we divide this term by 8, it gives us h out of 16. Yes. So from here now we say therefore we shall turn it to 0. We shall substitute the h as 0. So finally dy dx equals to x out of 8 plus h0 out of 16. What is 0 divided by 16? Is 0. So we shall have on x out of 8 as the answer. That is the answer when we are differentiating part C from first principles. Before you go, quick check. You have the function y equals to x squared out of 16. Let us apply the laws of powers and coefficients to differentiate. So here dy dx becomes, uh, what is the coefficient here? You can say the coefficient is 1 out of 16, or you can say the coefficient is 1, no problem. So we have 1 times 2. Then x or 2 minus 1 out of 16. This means we have 2x power 1 out of 16. Simplify, we'll have x out of 8. So that is the answer when we are using the method of powers and coefficients.